Hello, let's do the New York Times Hard Sudoku for July 14th, 2024. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, we'll start here. We've got 5, 6, 7, so we look for buddies. So there's a 5 up here. There is a 6 down here, and 7 does not have a buddy. Poor 7. All right, 3 and 9, we have a buddy for the 9. So these 9s look in, there's a 9 right here. Now this 5, 6, 7, yep, I suspected. So we have our, oh, I miscounted. I was very excited. We're actually really close though, so is there any way I can salvage that? Not yet. So we have this 5, 6, 7. What I was going to say is they can't go here, so they need to go here. I am noticing the 6 is limited. That's actually useful. In fact, we can place a 6 in this box, so let's do that. But what I was going to say is 5, 6, 7 need to go in these cells, and I thought it was 3, but I counted wrong. It's 4. But this cell here, I said it was close because this cell here can't be 5 or 6. So if it also couldn't be 7, which would only be possible if this was a 7, then we'd have 5, 6, 7 here, but we don't have that. But I did notice the 6. So if we look at this column, the 6 can't go here. What am I talking about? All right, the 6 can't go here or here, so it ends up here, is what I was going to say. But then I looked at this box, and we have all these 6s looking in. So I just spent way too much time on getting that 6, but that's okay. And then that also tells you that 6 goes here or here. So you can find that multiple ways. I don't think the 5 or the 7 is helpful at the moment. Okay, so let's go back up here. Did we miss anything else here? We got the 9 and the 3, so how about this 5, 6, 8, 9? Threes are interesting. This 3 looks up, this 3 looks in, and the 7 does the same thing. This time I'm actually looking. So whenever I see digits looking in a weird way that restricts it to 2 places, I try to remember to also look to see if we have another digit doing the same thing, because that gets you the hidden pair that you need. So 7 and 3 looking like this, 7 and 3 looking like this. So where do 7 and 3 go in this box? Well, they can't go on top of the 8 and 9. So we need 2 cells for 3 and 7. They go here. So this is this is called a hidden pair, because 3 and 7 are hiding in these 2 cells, which means that when you find a hidden technique, it removes anything else that could have been in those cells. So for example, there's no reason to think this couldn't have been a 1, except if we make it a 1, then 3 and 7 can't both fit in this box. And so it can't be a 1 for that reason. You can always find a naked technique that's complementary to the hidden technique and vice versa. So there's a total of 5 open cells here. So if we found a hidden pair that uses up 2 cells, that means the remaining 3 cells are a naked triple. And so naked triple just means if you were to pencil what these could be according to Sudoku, they end up being a set of only 3 total unique digits. And so those are going to be the 1, the 2, and the 4. So if you were to look at these cells, you would see that they can only be 1, 2, 4. And that's just because they can't be 3, 7. And so we could have penciled these and seen a 1, 2, 4 triple, and then that also makes this a 3, 7 pair, because 1, 2, and 4 we get eliminated from them. So it's the same exact thing seen in 2 different ways. Often finding, if you're not penciling every cell, finding the hiddens is easier. If you're penciling every cell, you're kind of hiding the hiddens. That's why they're called hiddens, and they can be a lot harder to see. So you end up finding the nakeds instead, which can be a little bit harder for us to spot sometimes. Anyway, just thought I'd go over that again because I haven't talked about it in a while. Okay, so we got this 1, 2, 4. We got this 3, 7. Now, what do we do with that? Unfortunately, the 1, 2, 4 is completely unrestricted. But these can't be 1, 2, 4 anymore, and that's kind of what we want to look at just to double check if there's anything we can do with that. There is. It's kind of crazy. So I was looking for 1, 2, 4 in this row, and I saw this 2 C's here, this 2 C's here, this 2 C's here, this 2 C's here. And this can't be a 2 because of our hidden 3, 7 pair. So this row needs a 2, and it can only go here. So that's a 2. Now, I don't think we can do the same thing with 1 and 4. Certainly doesn't look that way. But we did get this 2, so is there anything we can do with that? Well, we do have these 2 2s looking up, so we can put 2s here. That's not really affected by this 2, but I figured I'd do it. We also have these 2s looking up, putting 2s here. So when we did the verticals, I would have eventually seen this because we'd have these 2s lining up. telling us that we needed a 2 in this row in this box, and then it would only be there, but I managed to spot that a bit early. Okay, so I'm seeing a couple other things I want to investigate. We've got some empty cells that avoid corner marks, a decent number of corner marks, especially this one. Can't be 2, 5, or 6 in addition to 3, 9. It also can't be 7. So let's think about what this can be. It can be 1. It can't be 2, 3. Could be 4. Can't be 5, 6, 7. Could be 8. Can't be 9. I was really hoping it was a 1, 4 pair, but can also be 8. Okay, I was going to look at these as well. So they're down to 4 digits, right? Because we've got 9 digits total. And then this is 3 and this is 2. So that's 5. So 9 minus 5 is 4. So anything else that looks in, like this 1, is going to be super helpful to them. So the 1 can only go here. 2 is taken. We need a 3 that can go in any of them. A 4 that can go any of them. 5, 6, 7. And then 8 and 9 actually can't go here. And then oh yeah, 9 was cornered anyway. But that means that the 8 is up here only. So we covered 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So that's how those pencil. They all saw at least one thing. They saw 2 things. But I don't think we can do anything with that at the moment. This 1, 3, 4. Yeah, see, the problem is, right, we've got this 1, 3, 4, 7, right? And I'm always like, maybe there's some kind of triple or quadruple we can find here. But then we see that the 6 is cornered here, right? So these cells are at least 6 in addition to that. So we're not going to be able to find any kind of like pair, triple going on, quadruple even. All right, so I think that's all I want to do in this band for now. Let's move on to the next band then. Okay, yeah, let's move on to the next band. So I got this 3 and 1. The 1s do look into here, putting a 1 up here. We also have the 3. The 3s look into here. We don't have a 3 helping out, unfortunately. So there's a 3 just in one of these two. We also have the 1, 2, and 8. So these two 2s look in here. This 2 looks down that we found a bit early, which is nice. So that places the 2 here. Let's follow up on 2s a little bit, because we can place it here as well. If we double click the 2s, yeah, so we're just down to this rectangle of 2s, and all the other 2s are placed. So anytime we scan now, we can just ignore 2. So now the 1 and the 8. Oh, I did the 1 and the 8 already. I did the 1. I haven't done the 8, but I don't think there's anything to do with the 8, is there? I don't think so. I'm going to look for stuff looking through here, like the 5, 4, 6. Ooh, that's actually really nice. Ah, so what I missed, and when I was looking at this 5, 6, 7, right? I actually hadn't gotten to this box yet, really. But I remember I was trying to fit 5, 6, 7 here. Well, actually, we can fit 1, 2, 8 here. Or alternatively, we can fit 4, 5, 6 in here. You often find like 2 sides of the same coin there as well. It's not guaranteed, but it is guaranteed if it's 3 givens that are blocking the 3 places to place to reduce it from 6 to 3. Does that make sense, right? Because you can have other things blocking that, right? You could have like 1, 2, and 8 all in this row instead of the 6 placed. And in that case, you don't get the back fill. But anyway, so we have this 1, 2, 8. So these cells can only be 1, 2, 8 because we need to put 1, 2, and 8 in this column. And we need 3 cells for that. And these are the only 3 cells that can do that. So we can't put any other digits in here or they'll block one of the 1, 2, 8s from being placed. So that means this can't be 9. So we can actually just place this 9 right away. And then we can just fill 1, 2, 8 in here. This is not 2, as we know. And then this comes back in here, and that makes this a triple. But we can also say that it makes this, we also can see this hidden triple, which sometimes is a little easier because we already have the reference digits, right? So this is 4, 5, 6. This can't be a 4. This can't be 6 because of the column. But importantly, this can't be a 3. So it actually places the 3 in the box. And then this is going to be a pair. And it's going to be the 7 and 9. This 9 tells us the order. So that's the 9. That's the 7. Very nice. That was an important spot for sure. Let me know if you spotted that as well. Okay. You could have spotted it by penciling these 3 cells, by the way. These 3 cells were a 3, 7, 9 triple for the column with 3 only here in the column. So another way to spot that. Let's see. I'm looking to see what this did. Let's look horizontally for what this did. We did get 2 9s here. So there's 9 one of these 2. So this 9 helps. I'm looking at the blue digits, right? We got the 3, we got the 7, we got the 9. I'm thinking about the 7. I don't think it does much. This row also got reduced to 4 open cells, so it's good to think about it. We need 4, 5, 6, and 8. This cannot be 5 or 6, so this is 4, 8 only. This can't be 4 or 6, so this is 5, 8 only. So 6 in this row is actually only here. Let's double check. Yeah, that sees a 6, that sees a 6, that sees a 6. Crazy. Another one of those. So we get the 6, the 5, and the 4 because of the row, which is very nice. Gets us this 8 and this 5. That's not a 5 anymore. Okay, we should be able to do a lot more with this band now. It's almost done. So I got the 4. Let's see, what's the best thing to be looking at here? The 5 looking in here and this 5 looking up does put a 5 here. The 5's already placed in this box. All right, I'm just going to think about what digits these boxes need. It might be faster that way at this point. So we need 1, 6, 7, 8 here. So we know that 8 joins the 1, right? 1 and 8 can only go here because we have this 1, 8 looking in. So this is a 1, 8 pair. And then that means this is the remaining digits, which I already forgot, 6 and 7. So this 6 tells us the order. That's the 6, that's the 7. This 6 places this 6. Now we have 1, 3, 4, 7 here. This can't be 3, also because of the box. So this is 1, 4, 7. Okay. Not super exciting. But let's finish this here. So this cell is just finished for the row. If I can find the missing digit, it's a 4. That's a 1 and a 4. So we can clean this up a bit. We got the 1, we got the 4. Did we learn anything from that? Yeah, so 4 is in one of these 2 cells in this box. That's going to point down. I don't think I can do much with it yet, but probably useful once we get down to this band here. Let's do this triple. So we have 1, 2, 3, 4, 5. We need 6, 7, and 9. This middle cell cannot be 6 or 7, so it can only be 9, naked single. This is 6, 7. This 6 tells us the order, 7 and 6. That gives us the 3 and the 7 here, giving us the 8, 2, and 1. Okay, we get our 3, 4, and 1. That places the 4 here. Okay, we didn't need the pointing for us. We placed it. That's a 2. We get our 8 and our 1. We're going to finish the top 2 bands before we even get to this bottom band here. Let's place that 8 for solidarity. Give the bottom band something to do. We've got the 8 here, and then here we have a pair. We need a 5 and a 7. Okay, so the bottom band gets to resolve this 5-7 pair. Yay for bottom band. All right, well, I think at this point, looking vertically is just the way to go. Just honestly, we just pencil all these verticals and the puzzle will finish. We'll start with the ones with 2 left. So here we've got 1, 2, we need 3 and 7 here, not resolved. Here we need 1 and 3, not resolved. This is 3 left, this is 4 left, this is 2 left. We need a 4 and a 9, not resolved. Oh, this is a single. This is a 1. Didn't immediately help. This is a pair. So we've got 1, 2, we need a 3 and a 3 and an 8. Okay, none of the pairs are resolved. So let's do the triples now. So we need a 1, we have 2, 3, 4, we need 5. This can't be 1, 5, so this is going to be the other digit. This is the 9. That gives us the 4 and the 9. This is 3 or 7, can't be 3, so we get our 7 and our 3, and this did resolve the top band there. Now we get our 7 here. Okay, so now we just think about what this box needs. It needs a 4 somewhere. That's placed. It needs a 5 somewhere. Not placed yet. The 5 ends up in here somewhere. We need an 8. 8 ends up right here. That's 3 and 8. That's 1 and 3. 5 and 1. That's our 5. Last digit's 9. And we're done. This was kind of a fun puzzle, but it was interesting how basically the top 2 bands resolved themselves without too much help below. Maybe I found the important help below early. I'm not sure. I think definitely one of the most important spots of the puzzle that probably trivialized the rest of it was this 1, 2, 8. Finding the 1, 2, 8 triple here. Very important. It did require finding the 6 first. Not sure how hard that 6 was to find. Probably it was literally just a hidden signal in the box, so you just had to find it at some point. But yeah, that was important. Otherwise, I don't really have a call out. Maybe this box here. We had the 1, 2, 4 naked triple versus the 3, 7 hidden pair, whichever one you found. That seemed important. I'm not sure exactly what it. And then also the 1 spot in this row, and there was a spot in this row as well. There was a hidden. I think it was this row. That was pretty neat as well. So I think it was the 2 maybe. No, it wasn't the 2. I don't remember what it was. Cool. Well, hope you enjoyed this. And if you did, then why don't leave a like, subscribe, and a kind comment below.